All right, so let's take a look at what is this mole concept all about. Now, first of all, when you study about the mole concept, you're going to have the idea that it's a quantitative topic. That means it allows you to go and calculate how many atoms there are or how many molecules there are in a certain amount of a substance. Right, so you know that all these number of atoms and molecules are very difficult to visualize because in small amounts of water, you can have like trillions of atoms and molecules. Right, so that's why you need to use formula to help us to get the numbers. Right, so that is the purpose of studying this topic on mole concept. Right, so in the first part of the notes, remember your teacher has mentioned to you about Avogadro Constant? Right, does it sound familiar to you, Avogadro Constant? Yes, it does, right? Some yes, some no. You learn Avogadro Constant? Yes, okay. What about Nathan? Have you heard about Avogadro Constant? Okay, so we're going to start off with Avogadro Constant first. Now, there's so many words to read in notes, all right? But not to worry, we are going to summarize everything first. So let me share with you what is this Avogadro Constant. Now, if you go and read the notes on the own, I don't think you understand. All right, so first, when we talk about Avogadro, yes, yeah, Charlotte. Sorry? No, they are the same because for the pure chem and the combined chem, the only difference in the mole concept is that yours do not need to do concentration. Got it? So this is the common note that we share between the pure and the combined one. Yeah, so not to worry. All right, all that I've taught you that I'm going to teach you are the relevant ones. All right, so for Avogadro constant, you need to know because it's in your syllabus. All right, okay. All right, so let's talk about this Avogadro constant. You know that this one has a special number of 6 times 10 to the power 23, right? So how do we use this number? Now let's see if I have 18 grams of water. You know, 18 grams of water is very little, right? 18 grams of water is equivalent to the probably 18 cm cube of water. Why? Because you know that the density of water is actually 1 gram per cm cube, right? So if it's 18 grams of water, means that the volume is about 18 cm cube. So if I have this as 18 grams of water, what do I have to do first to find the number of molecules? So I'm interested to find out how many molecules there are in 18 grams of water, how many atoms there are in 18 grams of water. So we have to convert this to the number of moles. All right, so the question is, what is mole? Now, mole is actually a quantitative symbol, or call it as a collective noun to measure the substances that we have in chemistry. So let's say if I have 1 mole of water, right, 1 mole of water, how do I convert this to 1 mole? Now, if you look at your mind map, right, can you see that there's a conversion in the mind map? For every conversion of the mass given, we want to convert to moles, you have to divide by the MR. Got it? All right, I can also use a triangle relationship to help me to do that. All right, so if I have mass, I can take the number of moles times the MR, or if I want to find the number of moles, I have to take the mass divided by the MR. So like in this case, 18 grams of water, how to convert to moles? 18 grams of water will be equivalent to 18, which is the mass of the water, you divide by the MR of water. What is the MR of water? This, you have to refer to your periodic table. I'm sure everyone has a periodic table? No, okay. So I don't have a copy. Could you give me a minute? I'll go and get a periodic table for everyone. And Nathan, I'm sure you have a periodic table with you as well. Okay, so if you look at the periodic table, to find the MR of water, it's simply the 2 times 1 plus 16, which is also 18. All right, so 18 divided by 18, it gets you to 1 mole. So in other words, 1 mole of water weighs 18 grams of water, right? Weighs 18 grams. So if I want to find out this 18 grams has how many molecules, what do? Look at your mind map again. Could you see that there's a formula that relates the Avogadro constant to that of the number of moles? So it says that 1 mole, right, 1 mole of any substances, in this case water, will have 6 times 10 to the power 23 particles. Right now, this particles is a general term. The particles can be referring to molecules, can be referring to atoms, can be referring to ions as well. Right? So it depends on what is the entity that you're looking at. Like for example, water. Water is a compound, right? It exists as molecule. So when I have 1 mole of water, which is 18 grams of water, it means that there are 6 times 10 to the power 23 molecules, not atoms, not ions. So you must get it right. Right? Because sometimes they can actually give you another example, like maybe noble gases. You know what are noble gases, right? Noble gases are those elements in the group 0. Noble gases, they don't react. So they exist as what? As atoms. So if I have 1 mole of helium, okay, 1 mole of helium, it will therefore be 6 times 10 to the power 23 atoms and not molecules. Got it? So you have to be clear that these particles are just a generic term. Alright, so what is a specific entity? It depends on the substance that you're referring to. Okay, give you more examples, then you'll get a clearer understanding. So as I mentioned, 1 mole of helium. Now because helium does not react, it exists as atoms. So it means that 1 mole of helium is equivalent to 6 times 10 to the power 23 atoms, not molecules. What about 1 mole of carbon dioxide? CO2. So what's carbon dioxide? Carbon dioxide is a molecule, right? So it should be 6 times 10 to the power 23 molecules. Got it now? Right. So the idea about Avogadro constant gives us a clearer picture on how to calculate atoms, molecules. That's all. Right? Any questions? If there's any questions, just feel free to ask. Alright, don't be shy. You just have to clarify on that for starting conflict. Right? Nathan, okay? So I think silence means consent. If you didn't have much questions, means if you are silent means that you didn't have much questions, right? Okay, can. Alright. So anyway, let's move on. So how do we calculate the next formula that you see in your mind map? I can see that the mind map I've given to you consists of concentration. So concentration, you don't have to work on it at this point of time. For the combined signs, currently you only be doing the formula on mass, the formula on the volume of the gases, right, and also the Avogadro constant. All right. Okay, so the next formula that you see in the mind map involves the mass formula, which is this one. All right, which says that mass is equivalent to moles times the mR. Okay, moles times the mR. So if let's say a given number of moles, you have to multiply by the mR of the compound to find the mass. Right? Then what about the next formula? Okay, now the next formula involves the volume of a gas. Okay, let me share with you. So in your mind map, you will also see this volume of a gas that says the number of moles multiplied by 24 dm cubed will give you the volume of gas. Now you can only use this formula. You can only use this formula if it involves gases. Right? If it's like other substances, solid or liquid, you cannot use this formula. Right? Because gases are very sensitive substances. They are very prone to temperature, to pressure change. So this number is derived for gases based on room temperature and pressure. Understand? So that's why this formula is only meant for gases. So far so good? Yes. All right. Are there any other concerns that you have encountered in school with regards to this topic that you'd like to share? So far, can do the questions given in school homework, is it? Okay, great. Oh, your teacher didn't teach, oh. That part is actually for pure science, more focused on pure science, but you still need to learn this. I think most of you learn Avogadros, right? The teacher did mention about it, right? What about Elijah? Yeah. You know why? Because